All right, class, here we're going to look at law of cosines. Um, oops. Law of cosines. This is, we're going to use this when you're given side, 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 or side, angle, side. So if you're given all three sides of a triangle, you use law of cosines. Or if you're given side, angle, side, meaning the angle is in between the two sides, then you also use law of cosines. Okay, well, what is law of cosines? Law of cosines is this. Okay, and this is also on your sheet. There's two forms that we like to use. You get this form, and you got this form. Okay, these two are the exact same formula, just solved for different parts. So this is if you're looking for an angle, you're going to want to use this formula. If you're looking for a side, you're going to want to use this formula. All three of these are the same. So if I want to look for angle A or side A, I'm going to use this formula. If the first thing I want to find is angle A, I'm going to use this formula. If the first thing I want to find is side B, I'll use this formula. If the first thing I want to find is angle B, I'll use this formula. Okay. Side C is this one, and angle C is this one. If you notice, this is really close to Pythagorean's theorem. Turns out the Pythagoreans were really close to being able to solve for all triangles. But for thousands of years, they didn't know that this part was canceling off. If you look down at this one, this is maybe the easiest to look at. If this is a right triangle, then C would be the hypotenuse, right? And angle C would be 90 degrees. Well, what's the cosine at 90 degrees? I'll give you a second to think about that. But if you have your unit circle, cosine is the x value. And if you go up to the top at 90 degrees, what's the x? Well, that's 0. So this part cancels off if your angle is 90 degrees. So this is actually Pythagorean's theorem, but this part was always canceling off for them. So they used this for thousands of years, thinking they had their world was perfect because they thought right triangles were perfect and all the other triangles were not good. But it turns out that this part was just canceling off for them. So we came along and now we have a full formula. This formula works for right triangles and non-right triangles, which is what we're looking at today. Okay, so we're going to solve in the problem we got. Example 1, we're given side, side, side. So we're going to use one of these three formulas to solve for the angle first. Okay, so I have it set up down here. Now, rule of thumb is if you use law of cosines for this whole problem, then it doesn't matter which angle I solve for first. But if you like to switch from law of cosines to start with to law of sines to finish the problem off, then you want to solve for the smallest angle first, which is always going to be opposite the smallest side. But we'll just go use law of cosines for this whole problem. So first we're going to solve for A. So solving for A, I'll write down the formula. So it's going to be cosine of A equals B squared plus C squared minus A squared divided by 2 times B times C. We can put this all into our calculator. Okay, make sure you put this into your calculator properly. You got to put the top in parentheses and the bottom in parentheses, or you can do what I'm about to show you here in the calculator. So anyways, we're going to put this all in the calculator. So b squared would be 19 squared plus c squared minus 8 squared divided by 2 times 19 times 14. Okay? So putting this all in the calculator, inverse cosine, I'm going to hit the math button, I'm going to hit left, and put a fraction in there. Okay? Then I don't need to worry about parentheses. There we go. Right? If you don't use parentheses, or if you don't use the fraction symbol, then you got to put the top in parentheses. And the bottom in parentheses. So there's two ways you can put this in. There we go. Both end up in the same answer. So we get an angle of 22.08. All right, now we can solve for angle B. Angle B is going to be, so cosine of B is going to be a squared plus c squared minus b squared divided by 2ac. Okay, putting numbers in, inverse cosine of a is 8 plus 14 squared minus 19 squared divided by 2 times 8 times 14 and my 19 look the same. So this is what cosine should equal. Or excuse me, angle B should equal. So inverse cosine, math, fraction, 8 squared plus 14 squared minus 19 squared over hit enter, 116.8. Now, to find angle C, just going to take 180 minus that angle minus the other angle, right? Because the three angles in a triangle should add up to 180. So this angle should be 41.212. All right? Now, simple check to see if you're right. Well, not necessarily if you're right, but well, yeah, you can check to see if you're right. Here's how. So we get rid of that. So if I'm correct, the sine of A divided by 8, divided by little a, should equal the sine of B divided by little b, which should also equal sine of C divided by little c. So you can put that all in your calculator. But a simple check also, this side and this angle. This angle is the smallest angle. It should be opposite the smallest side. This is the biggest angle. It should be opposite the biggest side. But anyways, we can take a look at sine of A. So take sine of that divided by 8, hit enter, okay, sine of B, which was 116, divided by B, and sine of the last angle we found divided by c. Okay, they're all the same. I just have one of them that looks a little bit rounded off, but they're all exactly the same. So that's how you can check on your test. Just check with the law of sines real quick. Whoa, what happened? Just check with the law of sines, but a real easy check is these angles should add up to 180, and the smallest angle should be opposite the smallest side, biggest angle opposite the biggest side. Okay, so hope this helps.